Welcome to episode 3 of Road to Network Engineer. I just wanted to share an update. It's been a couple of months. We've been in lockdown actually, so you can tell from my disheveled appearance. I'm keeping healthy and all that. So back to it. I passed my NSE4. Pretty good exam. It looks like the version 6.4 is retired now. So if you're planning on doing that, you're going to need to do 7.0. And something funny happened to me during the exam. I couldn't start the exam for like 15 minutes and I had to troubleshoot my way out of it. I used Chrome Remote Desktop and it was running in the background and I had to kill it from Task Manager, so that was not a fun time but stressful before an exam. So if anyone else uses it, probably just uninstall it before you take your Pearson VO exam. Again, if you're willing to do R2NE3, there's the self-paced stuff, and they've got videos on all these lessons, and you've got to take the security and the infrastructure. 2 different courses, and you need both of them. I've also got sample questions as well, which is quite good. And if you want cards, I've got some, but these are for 6.4, so probably not so helpful. This is what I'm working on now. This is Ruckus, and CommScope bought them out, so they're CommScope now. Ruckus, they have some good online training, just like R2NE3. And I'm looking at the Certified Networking Associate exam, and along with that there's some accreditations with their Smart Zone Cloud Controller for Wi-Fi. Sorry, this is ICX, so this is like the switching. And this is the cloud controller, and this is Cloud Path, another solution they've got. So all 3 I use in work, and I need to know them quite well. So that's why I'm planning on getting this exam done. It's a 63% pass rate, 60 questions, so not too bad. It's $150 US, not as expensive as a R2NE3 one. Yeah. What's great about that is I just enrolled in, say, the associate that I want to do, and it gives you all the trainings you need. So many. I'm not sure how long it's going to take me to complete. Hopefully by the end of the month, and then I'll see when I want to do the exam or not. I might take a break in December. So I finished this ICX implemented, that's the switching one. And there's plenty more of like trainings that they've got that are unrelated to this, just if you want to learn Ruckus. It's just a great resource. Just a bit of background. APNIC is the Asia Pacific Internet Registry, big guys in the internet, and they've got some training that I thought was worthwhile. So one of the things that was cool was the routing fundamentals, and then they've got this lab that you can spin up and you can use for 2 hours. So I'm just going to go and talk about that now. So it's finished loading. They give you the login details. They're going to do it too fast. Okay. So yeah, you can see they're running 15.1 GNOS. And what's cool about this is you can just click it and it will type in those commands. So you don't have to do all this manual config because you pretty much know how to do these commands already after you've done them, a couple of times. This is just assigning IP addresses. So this is the first part. I'll just skip over that, and it kind of breaks it down into IPv6, IPv4, and verify the connectivity. You can switch between the routers very easily just by clicking on these hyperlinks. And I just thought it was a great resource, and I think lots of people should check it out. The last thing I wanted to go through was some things that I've learned over the last 2 months. Starting my new job, I work with R2NE3 now, so there's a lot of information to learn and the test, the exams, but I don't think you need all of it. I think the most important stuff is like the troubleshooting and like understanding the diagnostic commands. This is just a small lab I've made to test commands and just show some things. So firstly, I wanted to go through like how Sniffer works. From this computer, it's 1.10, and say you want to ping the, just run some connectivity. That works, but say you can't ping the internet interface. What do? Again, the diagram, it's this one here. 2.2 is the internet interface on the Fortinet, the internet facing one. So you might be able to ping that if it's enabled. So diagnose sniffer packet, this is the interface, this is the host, and that's the IP address, and that's the number of captures it's going to make, and that's the verbosity. So we can see what it's doing already. It's trying to get to Google, it's trying the secondary and the primary. That's the port, UDP53, so you know it's DNS. That's UDP. So that's just traffic it's doing by itself. So if we try and run that ping again, we'll see that it's sending ping requests, but there's no replies. Just so that's something to note, we're not getting the reply packet back. Say also we can increase the verbosity for the sniffer, so that changes what we can see. So you can see the packet payload and the Ethernet headers and stuff like that. So if we go to the actual device and say we enter, so you can see facebook.com there is coming through now. And that's just a way to kind of get more information about what the packets are doing. I think that's useful. So there's also the time, port, source port, destination port, again DNS. It's looking up Google. You can't ping 1.1.1.1, there's just echo requests, there's no replies. So what could this be? So firstly we'll look at that interface. We can see that ping is enabled on the interface, which is good, and HTTPS if we want to manage it from that network. So that's all good on the interface side. But with the firewall, of course, is there a policy to allow the traffic between those two hosts? So of course, this is just testing one, there isn't a policy. So this is the policy that we'll need from port 2 to port 1 to allow that traffic. We'll see what happens when we allow that. You see now it's working, which is great. I'm just going to disable it again. So say we want to ping the first hop router, and we're not getting anything back. We kind of want to do some troubleshooting. So there's another command, sniffer, but you can specify the destination. So now we're being a bit more specific on what we want to capture. Is it still going? So we can see again, it's one-way traffic, and you should be seeing traffic both ways. So we know something's wrong there as well. That's just how you can filter more granularly. So another way of troubleshooting is by doing a flow trace. So flow trace will show you what the traffic's doing. Like in this case, it's trying to get to the DNS, but there's being blocked by policy 0. That's the implicit deny. So that means there's no policy to allow that traffic. So how does that help us in our case? Again, if we're running that thing, we can see that traffic is trying to get there 2.2.2.1 and it's failing the policy check 0. So again, that means we need to create a policy. So what I'm going to do is I'm going to enable those policies, and we'll see that it now, not only is it working, but that it's not getting that same error message. So when it's being allowed by a policy, you know that that's all good. So now we do another trace start. We can see it's getting source netted out port 1, and this is the source, this is the destination. So it's now working. We can get to that router. So when creating firewall policies, you'll notice there's 2 firewall policies here. One is for getting to that 222, and one is just any to allow all internet traffic. But you'll notice, so you wouldn't have NAT enabled trying to get to an internal interface, and you would have NAT enabled when you're trying to reach an external interface. What's good about Fortinet is it's quite intuitive, policies and objects. That's when you find your firewall policies and your virtual IPs. Those are the main ones that I've used. So for logs as well, if you want to find logs, you can just right click and you can see that it's allowed in the ID. Another interesting part is the static routes. So you can't ping 1.1.1.1 for example, and if we check the Fortinet traffic, so it's saying there's 2 default routes, which doesn't really make sense. So this is some management stuff that I'm doing, and it's broken stuff. So that's why we need to have a static route to 1.1.1.0, so the traffic from the hosts can get to this side of the Cisco, so this other network, because the Cisco router is already set up correctly. So now we'll see that traffic can come through. So there's kind of a couple of things, and if we go, you can see that it's now coming out port 1, whereas we probably don't want this default route, so this should be disabled. Thanks for watching.